wanted to talk about today is a kind of a proof of concept experiment that we carried out across two trusted research environments. So those two trusted research environments, or TREs, are short, also known as safe havens. That was the SHAIP, which I'll talk about in a second. And then a second one called FLIP, which is based in King's College London. Now, my role is I'm a senior scientist in the AI research department at Canon Medical Research Europe, based here in Edinburgh. So I'm going to be telling you this story from a point of view as me as a scientist. And we're going to see that that's going to be important. So we start off then with the data. Now, data's got very obviously extremely useful. Talk about the string segmentation and so on, and to train these AI models, we need data. Now, the thing is this, that when we're talking about medical data, sometimes, not always, but sometimes data is unconsented. What we mean by that is that there has not been specific permission given by the patients for that data to be used. Now, under the UK law and European law, there are use cases, there are legitimate use cases where that data can still be used. And typically what you'll find is those use cases, that data will be de-identified. And there's a lot of work that goes into that step. I've shown it here of de-identified, but there's a huge amount of work that goes into de-identifying that data. Even when it's been de-identified, there's still extreme vigilance as to how that data is handled and who has got access to the data and who's got the ability to see it and what can be done with any products that come out of that data. So typically what you'll find in the UK is very often what you'll get is what's known as a trusted research environment or a safe haven. And what happens here is we start off with the data on the left-hand side. And this is our data, which is the unconsented data, and it might be CT images coming from PACS, or it could be the medical records, the labs, the documents. And this is going to be ingested into a safe haven. Now, here's me as a scientist, and I really want to get hold of this data. I want to be able to do some training of some AI models using this data. Now, to do that, I'm using the Safe Haven AI platform, which is the platform which has been developed by Canon. They use what's known as a bring your own tools approach. I can upload to this environment any tools I want inside a Docker container. So I'm now able to do PyTorch if I want, TensorFlow I want, you name it. As long as I could put it in a Docker container, I can run that code. But really, really important difference to perhaps some other approaches is that within this trusted research environment, I have absolutely no internet access. So for example, I couldn't use weights and biases. It wouldn't be possible for me, no network access. I'm not able to export. I'm not able to connect to a Jupyter notebook out externally. I can run a Jupyter notebook within the environment, but absolutely nothing I can do. I can't cut and paste data out. I'm forbidden from doing that. So it's a strictly controlled environment. And the person in control of that, well, that will be the data manager. We've got two really key persons here, two main roles. That's me as a scientist wanting to do the AI research, and then we've got the data manager. Now, I come along and say, I want to do federated learning. Well, that, you all know, involves now talking to a another computer, which is now outside of this trusted research environment. So if that's the case, well, the data manager needs to be in control of that process and needs to be aware of that process. So we need to break down federated learning, as far as I'm concerned, into two roles. From my point of view, there is the code, the Python code, the TensorFlow, the TensorBoard, the AIM, you name it. The code which is going to describe the AI model and how I'm going to train that AI model. And then there's the second part of it, which Chris and the others have been talking about, provisioning and networking. Now, all that side, I've not been involved in personally, because that's now involving networking, and that is completely out of my control, because the data manager wants to be the one who's controlling what is coming in and out of this trusted research environment. So we've got a dual role going on, and it's the approach we need to take for federated learning in that needs to take this into account. So let's see how we go about this and what experiment did we try. So here's what we wanted to try, the aims of our experiments that we carried out with King's College London. So King's College London, they're kind of platform called FLIP. That's a Federated Learning interoperability platform. And iCAIRD is a consortium involving Canon, but also kind of two NHS trusts in Scotland, Glasgow and Aberdeen, or Glasgow and Grampian. Grampian is the county. And you wanted to see, could they collaborate in a MONAI FL using NVFlair as a background tool as well, using, first of all, the NVFlair bundle, sorry, the MONAI bundle that should be. And then we wanted to run a second experiment where this time the MONAI FL hub was going to be hosted by kind of a SHAIP and iCAIRD client, iCAIRD kind of trusted research environment. And we wanted this time to be able to use custom Python code. And we wanted in both cases to be able to connect from the MONAI FL hub, wherever it was, to the FL clients and FL servers in the different places. Now you've noticed things slightly different going on here as well. It's going to come back into a second. We have the MONAI FL hub is not connecting directly to clients, but indirectly. Let's come back to that in a second. Let's break down these experiments. As far as the kind of the test case for our experiments was concerned, we wanted a realistic test case. So we've seen that with brain segmentation. So what we went for was brain tumor segmentation using the kind of BraTS 2018 dataset. And we used MONAI's 3D segmentation pipeline, and that's again publicly available on GitHub if you want to kind of Google that. It's very easy to find. So that was the basis for our AI training code. We were really interested in here in the proof of concept. Could we connect these two trusted research environments together, and what would be involved in that? The 2018 data set is convenient because the institutions are listed, and it makes it very easy to make it into realistic splits across the two trusted research environments. So for experiment A and experiment B, you've got a couple of network connections going on. Again, this is the responsibility of the data manager, kind of within the kind of the SHAIP and the FLIP platforms, but they took care of that. So all the provisioning, all of that side, that was carried out by the data managers in the two platforms. And that was set up, and me as a scientist, yes, I was aware of what was going on, but I didn't personally have responsibility for that. So here's the first experiment we wanted to carry out then. Experiment A, and what we had here is King's College London and the kind of FLIP were going to kind of host the MONAI FL hub. Let's just take a look at what's going on here. So we start off with the MONAI FL hub, which is doing the controlling and aggregating of the model weights, and it begins the experiment. Now, the message then that is sent, message 1, start training round, doesn't go directly to a client, but goes to what we call like a mid-tier server. And the idea of this is, generally speaking, that what we might have in the future is multiple kind of federated learning platforms where each federated learning platform might themselves have multiple clients. So for example, you might have one based in Scotland with hospitals taking part in Glasgow and Edinburgh and Aberdeen and Inverness. You might have another one based in London with multiple hospitals in London taking part. And so we had went for a two-tier approach. And the idea is, well, yes, we both centers, SHAIP and FLIP, made advantage of the NVFlair code, but MONAI FL is independent of that. So the MONAI FL definition doesn't insist that you use NVFlair, doesn't do that at all. You're able actually to use whatever FL platform that you wanted to. So that was, again, would be the potential that within these gray boxes, you would take your pick kind of NVFlair or alternatives. But then outside of that, each one could be using a different potential FL platform. Once the message is then passed to the server, then the server is then passing the message to its clients, asking them to do a training round. When the training round is completed, again, it's going back up the kind of the layers to the mid-tier server, back up to the MONAI FL hub, where, as usual, the aggregation takes place and another round is going to continue. Now, for this experiment, we were using the MONAI bundle. That is, the idea here is that the code, the model definition is done in a JSON file. The reason for that is on the premise that, again, there can often be extreme level of vigilance, so you can call it nervousness or whatever you want, that they want to be the safe havens, trusted research environments that are very protective about the data, and rightly so. As we said, this is unconsented data. There are jobs on the line. There's reputational damage to be had if there's any leakage of data. And so they tend to be very protective of the data. And so to allow for that, what the MONAI bundle does, by defining the model in a JSON, you're having a very strict control over what code is being allowed to run on the platform. And so this is the extreme end. They're saying, well, the scientists are not allowed to run their own Python code on the platforms because, well, we're not sure about them and we don't fully trust them. So this would be one way to do it with the MONAI bundle. And this is what the MONAI bundle look for, like in our case. So you're able to choose a model of your choice and configure it and so on. The second experiment we carried out was one where now SHAIP and the iCAIRD is hosting the kind of MONAI FL hub. And again, it's communicating with the FL servers based perhaps in Aberdeen, and communicating with the Flip server based in King's College London. And very, very much the same approach, but one other crucial difference. In this one, we wanted to test, could you also use client algo? So with MONAI client algo, this time you're saying, well, actually, we do trust the scientists up to a point, and they are allowed to use Python code. But one crucial thing, I think it was Chris who talked about the ability to prevent code being shared automatically. I think that's something, again, is quite important, because as a scientist, I am responsible for whatever code I run within that Docker container. And so this code was shared out of band. And so the scientists at Flip, scientists at SHAIP, they are responsible for checking that code and saying, yes, this is legitimate code to train an AI model. It's not trying to do something nefarious like zip up a CT image and send it across the network. So I'm responsible as a scientist for making sure that's not the case. And yes, it will be audited as well. So that was the second experiment. So one more thing though, before we go just take a look how far we got on. We've got this little box here. And again, you're very familiar with this premise by now. You've got the server, MVFlare server, whatever it might be, and you've got a client. But there's a bit of a catch with regards to how we did that on SHAIP, because as I said at the start, the way I'm working as a scientist is that I'm bringing stuff into a Docker container and that I don't have any network access. So let's see how we managed to do that. So what we were trying to do then is federated learning in a Docker container without network access. So we've got these messages 2 and 3, and these are the messages that are going across the internet to the server. Form training round completed. And here with this training round completed, you are potentially sending data. What is that data? The data managers want to know that, and they want to be able to control that. So that process then has to be split into 2, because the data managers, they're responsible for the data. I am the scientist, I'm responsible for the code. So we split it into 2. Data manager, the client is actually what we call like a SHAIP NVIDIA Flare executor. And we then have to kind of break down the steps 2 and 3 into 2 sub-steps. What happens is this. When this client, this executor, sorry, is actually NVIDIA executor, when this NVIDIA Flare executor gets the request to do a training round, it takes the kind of FL message and it writes it to file, and then it launches the kind of the researcher's container. Now, that was made easy because, as again was mentioned previously, MVFlare is open source. So it was actually quite relatively straightforward to take a look at MVFlare, what's going on with the executor, and kind of what are the messages coming in, and let's take those messages and write them to file in the kind of things, the FOBs format, And then we wrote this to file. The researchers this my container with my Docker image specifying the code, which is now going to do the FL training, was launched. And within that container, I then took those messages from the file, reconstituted them to env flare kind of executor messages. Then I passed that to the instance. In this case here, we also use MONAI, the integration from MONAI. Thanks to Holger, did a lot of work on that. So we use that to kind of then kick off a training round. When then that had finished, what then happened in the training, my container had then finished it doing its training. It then writes the results back to file in the standard format, and it finishes. As soon as it finishes, the kind of SHAIP kind of scheduler detects that it's finished, takes those messages, reads them from file, reconstitutes them, passes them back up the line to the NV kind of flare server, back up the line, the MONAI FL hub. So bottom line, how did we get on? Did we get it to work? Well, the bottom line is yes, we did manage to get it to work to a degree. So we got the experiment running where KCL were hosting the hub, and we were using the MONAI Algo with SHAIP. Actually, I should have said earlier, sorry, to test it initially, we were using a deployment of SHAIP in Edinburgh as the client. That worked. And then we switched it around, and we had SHAIP at Edinburgh hosting the FL hub. And this time we used the custom algo, the client algo with that Python code, and the KCL client. And then finally, we had one more experiment where we had KCL hosting the hub, and this time a deployment of SHAIP at Glasgow acting as the safe haven client. We did run into some network issues trying to bring Aberdeen on board, and unfortunately we ran out of time to be able to kind of do that as well. But it was a lot of people involved, so thanks to all those involved. I don't have time to name all of them, but it was a big team taking part and helping with that mid-tier client, and also as well kind of getting SHAIP to work. So thank you very much. And again, if anyone's got any questions, I will do my best.
Great. Thank you, Jeremy. I got a few private messages asking if there were links or any other information you have on just the general use cases that you talked about in like the experiment. You have this presentation, this slide, but is there any other information people can learn about from those experiments?
Off the top of my head, are they referring to the experiments in terms of BraTS, or with experiment from the point of view, could we get it to work?
I think maybe more, I think on the could you get it to work, if there was a paper that you guys wrote on this at all, or is this presentation slide deck kind of like the best source of knowledge of what you guys did for that experiment?
I think there is an intention to actually write up a paper on this at some point,
okay.
But we haven't got around to that, sorry. But watch this space.
Okay, cool. Yeah. That was the only question that I have. Let's see. Okay. Yeah, I think that was everything. So thank you, Jeremy. If you have any other questions for Jeremy, you can put them in Zoom chat and we can maybe answer them sort of in chat itself if you do have any last minute ones. But again, thank you again, Jeremy. That was great.
Thank you.